So particle P is moving along the x-axis. It's moving along such that its position is given by x. Particle Q is moving along the y-axis such that its velocity is given by v. So we're given position of P and velocity of Q. So we're not given quote-unquote equivalent equations. So like when we're talking about them, we have to what, how, and what we're talking about. And 95% of what we're going to be talking about in this, I'm going to think is going to refer back to some variation of our F double prime table. Because anytime I read position, velocity, acceleration, I'm thinking of my table. So I'm thinking, okay, where are they going to hit me? Are we going to be talking about increase, decrease, in extrema, concavity, etc. So if you need to, you get scratch paper on the AP exam. Once you make this table once, you can keep it on your scratch paper for the entire day. You can take a Post-it note in with you and keep it on that. Now you can't go in with it, obviously, but I would highly suggest writing it down somewhere so you can easily reference it. Because when you're in that mindset and you're taking that test, anxiety, nerves, they all filter in. And if you have something to reference, you're less likely to get confused. So part A says, find the velocity of particle P at time t. How many points do you think part A was worth on the 2022 AP? 1. However, it's an easy 1 point, hopefully. Be very careful. So the one thing they were looking at was your response labeled? It does say an unlabeled response earns the point, but what that means is they're putting a hint out there in the future that if you don't put VPT, they may not get a point. So like they give us like scoring notes, and the scorers decided for this test if you didn't label it, you earned it, because like you fill in like the boxes or whatever. But I don't know, to me that's like a hint. So the derivative of position in this case, what they're making sure you do is take the negatives and make them positive. So derivative of 6 is 0, derivative of negative 4, e to the negative t, well e to the anything is the same. So you have the negative 4 times negative 1, which becomes positive 1. Or positive 4. That earns you 1 point. Part B, find the acceleration of Q. Find all times at which the speed of the particle is decreasing. Justify your answer. Speed involves both what? Acceleration and velocity. So in order for your speed to be decreasing, acceleration and velocity need to be opposite signs. Exactly. So let's find our acceleration. Personally, I'm rewriting my velocity as t to the negative 2 power because I think it's easier to see your derivative of the power rule. And then remember that when you rewrite that, the 2 stays in the numerator. It does not come to the denominator with you. So now I need to know when acceleration is 0. And when position is 0, or velocity is 0, so that I know when the particle changes size. So in this case, both of those times happen at 0. However, what do we know about something negative on top? It will always be negative. If it's cubed, it's only going to be negative when you are negative. If it's positive, it will always be positive. So acceleration is positive, is negative, always here, and positive always there. But we don't care about times plus and 0. But anything squared is always positive. So velocity is always positive. So for all times greater than or equal to 0, acceleration is negative and velocity is positive. Therefore, the speed of particle q is decreasing always. So because velocity and acceleration have opposite signs, the speed of the particle is decreasing for all t values greater than 0. Make sure you don't put equal to 0 because they did not include 0. So again, we would say that the speed, again, you almost want to repeat what they put in the problem, of particle q is decreasing for all t greater than 0 because the acceleration and velocity always have opposite signs. So now that we've answered the question, 1, 2, or 3 points. How many points is this problem worth? And what do you think would be worth your points? So the first part of the problem said, find AQT. So that's going to be worth 1 point. There's 1 point. Then it said find all t times when the speed is decreasing. Justify your answer. The justification is worth 1 point. You can't justify something without showing mathematically where it came from. So the consideration of acceleration and velocity when they change position or equal 0 is worth your other point. So the consideration of the signs is worth a point, description is worth a point, acceleration is worth a point. So part B is worth 3 points. If you did not indicate anything about velocity, like you only had acceleration was negative, you did not discuss velocity, you did not earn your point. So 1, 3. Find YQT find yqt, which is the position of particle q at time t. So we have velocity of q. How do I find position of q? You gotta integrate. So for part C, we're integrating what do we know about our problem at all? We know that at time t equals 1, the position is 2. So if I want to find the position of the particle in general, but I have an initial condition, I still need the fundamental theorem of calc. So x of qt will be equal to y of q1 plus the integral from 1 to t of 1 over t squared dt. So again, 1 over t squared is like t to the negative 2. The rule for antiderivatives is the opposite, right? So derivatives, you take one away. Antiderivatives, you add one back. So this would be t to the negative 1 over negative 1, evaluated from t to 1. We have 3 minus 1 over 2 plus 1. So again, what that means is that the initial position of the particle is 3. This is also worth 3 points. An integral in any way, shape, or form, any of those, or the integral in the problem, got you the first point. So you could have had any of those 3. That's what I'm like reading through. So again, our responsive presents the integral in any way, shape, or form, earned you the first point. So any of those 3 got you a point, whether you did anything with it or not. Okay? And then the second point was earned for using the initial condition. So having y of q1 or the number 2 here in your problem earned you the second point. So if you didn't use the initial condition or fundamental theorem of calc, I do not believe you could have earned any additional, like you can't earn the answer point because you didn't use it. So the final point came from the answer, which came from this. if you had done an integral without bounds, it says, and you put a plus c, but then you solve for c, using the initial condition earned you all 3 points as well. So if you thought of it as like an unbounded, you found your antiderivative and you put like -1 over t plus c, but then you found c using this, you also could earn all 3 points. I didn't think of it that way because I just see FTC, but I read it. So we have 1, 3, 3. So how many points can the last one be worth? 2. The last one should remind you of the ones we were doing like a couple weeks ago and like our free response problems. This is like that annoying limit one, but like I did so many of those this year because last year was the first time I'd ever seen it on an AP test. So it says, as t is approaching infinity, which particle will eventually be further from the origin? Give a reason for your answer. So we need to look at the limit as t approaches infinity for both particles. What stinks about this problem is that if you got the answer in part C wrong, you have nothing to take a limit to. Because you're taking the limit of the position. So the limit as t goes to infinity of a constant is always the constant. This is like -4 over e to the t. Well, e to the infinity would really be like a 0 or an infinity, depending on like, anyway, think about it, but like 4 over something really big or 4 over something really small is insignificant. Just like 1 over infinity is going to be insignificant. So this is going, plus an infinity, and then the other one is going to be a 3 plus a 0. So which one is going to get that? Because 6 is greater than 0, particle P will eventually be further from the origin. Oh, a response with an incorrect YQT from part C is eligible for boost points provided they